Okay, morning guys. This is 5.2, use perpendicular bisectors, and the objective, you'll use perpendicular bisectors to solve problems. First, you have to know what a perpendicular bisector is. When you take a segment and you draw the perpendicular bisector, it's two things. First, it needs to be perpendicular, and the second, it needs to cut it in half. So you would draw it in the middle and make a 90 degrees straight up. Because you drew it in the middle, those two segments would be the same. So what goes into your notes for the first page here? It'd be this diagram. Once you get that drawn in, line CP is a perpendicular bisector of AB. You need two things, 90-degree angle and two marks showing the congruent sides. Next thing that goes into your notes is this. And what I'm going to do is I'll show you something off to the side here, and then we'll actually start putting stuff in. Okay, so here's how it works. Again, here's a segment. We'll call it A and B. We're going to cut the segment in half, and we're going to go at a 90-degree angle straight up. And those are the same. Now, anywhere along that vertical line, you can make a point, and here's what you could prove. You could say that from that point to the letter A would be the same as to the letter B. Those two would be the exact same. Now, if we look over at this part over here now, that's what they're trying to get at, guys. They're trying to say that if you draw the perpendicular bisector, the two blue lines would be congruent to each other. So for your notes, please put this is your heading, this is your diagram, and this statement to go with it. Now, and just one more real quick thing here. You can make as many points along here as you would want to. So if I make another one up here, you could draw a line to the A and a line to the B, and those would be congruent again. And you could keep on going. Now, the other thing that goes into your notes is the converse of the perpendicular bisector theorem. And you're just going the opposite way around. So let's say, for example, that you had a point and you knew that these two segments were equal to each other, like so. Here's what you could pick up on. You could pick up on that if this was A, B, and D. You could pick up on that point D is along this perpendicular bisector, this vertical line right here. So that forces this to be 90 degrees, and those two are the same. So if those two outside ones are the same, then D lies on the perpendicular bisector of AB. Okay, so this problem does go into your notes. In the direction says that DB is the perpendicular bisector of AC. You need two marks, first perpendicular and bisector. Okay, now you grab the two segments that are equal to each other. If you have the perpendicular bisector on the perpendicular line to that outside part, those two are the same. Set them equal to each other. 3x plus 14 equals 5x. Quite often in this lesson, they not only want you to solve for x, but they want you to plug it back in to find a length of a segment. So AD. AD is on the bottom right here. Take your 7, put it by the 5. 7 times 5 would give you 35. The final answer for this one would be 35. So just be careful on a quiz or test. This is the converse. This does not go into your notes, but definitely follow along like crazy. Right off the bat, I'm noticing the 25s. Those two are the same. So point V, the one up here, and point W must be on the perpendicular bisector. So if it's on the perpendicular bisector, we could do this. 90-degree angle, those are the same. And that leads us into the first one here. What segment lengths in the diagram are equal? YX is congruent to XZ. The second set, YV is congruent to VZ. And the last set, YW is congruent to WZ. Part B, is V on WX? Yes, because we have the perpendicular bisector drawn. All right, I'm going to start up a triangle on the next page, and that'll bring us, and I'll come back and I'll talk about this in just a second here. But it's going to mean more if I just draw it out from scratch. So what I'll do is I'll get a triangle going here. Let's see if this is going to work. Okay, I suppose about like so. Okay. Oh, don't do that, don't do that. Oof, there we go. Okay, so I want to draw the perpendicular bisector, so I want to find the middle and draw a line straight up. Find the middle of the bottom. Now I'm just going to eyeball to speed things up a little bit, and then I'll go straight up at a 90-degree angle. I find the middle of this side. Let me label here. The middle of side AB. Find the middle. Get a line going that's straight out. And I have to bring this one down a little bit. Notice how they cross if you keep on extending them out. And then find the middle. Bring it out. Okay, now it's not perfect, but we did find that this outside one right here, they all meet up. And when you draw three perpendicular bisectors, they all meet up at a point that is called the circumcenter. So on this one, point D is called the circumcenter. Okay. If D is the circumcenter, here's what you can prove. Now, I'm not going to draw it yet. Just put your eyes on it. Imagine drawing a line from D to A. The line from D to A would be congruent from the line to D to B, which would be congruent to the line from D to C. All of those lines are congruent to each other. So if you have three friends and they all lived at A, B, and C, where's a spot where they could meet up that's equal distance for all of them? Be at point D. And to prove it to you, I have a feeling this is not going to work out well because I freehanded it, but let me give it a try anyway. If I get the tools going and I can get a compass going, and let's see if I can get this to work. So if I put that on the circumcenter and I extend this out, I wrap it around so it hits that. Okay, there we go, about point C. Okay, there we go. And now I'm going to wrap it around and cross my fingers that it gets kind of close to A and B. All right, it's going around. That's kind of close, and this one's way off. Okay, so, but if I would have taken the time to actually measure it out, all three would be a hit, and it'd be equal distance to all three. So back to this page here. What you should put in your notes is this. We have, this is your heading. This is what we can prove, or this is what they're talking about. This is what they can prove. This is the picture that would go with it. Okay, and basically point P is the circumcenter, so all of the red lines are congruent to each other. You could draw that with a acute triangle where it crosses in the inside. You could draw them with a right triangle where it's on the triangle. You could have an obtuse one where they cross on the outside of a triangle, and that's actually the one that I have here. This is an obtuse triangle, so the point crossed on the outside. Now, it looks like I should have basically, would have ended up a little bit lower if I made those at a more of a 90-degree angle, like hopefully so, give or take, you know, bring it down, redraw it, and away you go. And then this is literally the one they said that you basically have three different places. That's probably extremely hard to see. Go like this, 1, 2, 3. Where would you go to find the absolute center of all three of them? You'd make the perpendicular bisector. So you draw a line, find the middle, go straight up. Draw the line, find the middle, go straight up at a 90-degree angle. Find the middle, go straight up, 90-degree angle. So right about there. And again, I'm just doing freehand right now, but it's a 90-degree angle, and those are the same. 90-degree angle, those are the same. All right, that's it, guys. Good luck and have a great day.